Alright, today we're learning about the half-angle formulas. Just like the double angle formulas, we have some angle identities for half-angle identities. Here they are. There's 4 of them. Notice there are 2 for tangent. Neither one of them holds too much of an advantage, but later on they could pose an advantage based on what we know. Notice though they both have a sine and a cosine, so really there won't be much of a advantage. So let's start doing some problems. Cosine of A equals 3/5 in quadrant 4. I want to find the sine of A over 2. Well, let's write out my half angle sine. Sine of A over 2 is plus or minus the square root of 1 minus cosine A divided by 2. I know cosine A, so let's plug it in. Plus or minus 1 minus 3/5 all divided by 2. So I get 5/5 over minus 3/5. This is plus or minus 2/5 over 2 here. You can think of that as 2 over 1. So we flip this bottom fraction, which will give me plus or minus the square root of 2 over 10 plus or minus 1 over 5. Notice I'll have a 1 on top and a root 5 on bottom, so I need to rationalize that. I need to multiply top and bottom by root 5 over root 5. So get plus or minus root 5 over 5 as my answer. However, how do I know if I'm using the positive or negative one? In order to figure that out, we're going to use my full angle interval. Now to find my half angle interval, I'm going to divide all 3 things by 2. That'll give me an interval for A over 2. So the interval of my answer here is going to be 135 less than A over 2 less than 180. Notice that interval puts me in quadrant 2. So now thinking about the sine of A over 2, is sine positive or negative in quadrant 2? Well, that happens to be positive, using all students take calculus. So my final answer is going to be positive root 5 over 5. Similarly, we want to find the cosine of A over 2. So let's write down my cosine half angle formula. Plus or minus the square root 1 plus cosine A over 2. Plugging in what I know, plus or minus 1 plus 3/5 over 2. Let's do some simplifying again. Plus or minus 8/5 over 2 over 1. If you want to think of it that way, flip the denominator fraction, plus or minus, which will be 8 over 10, or 4/5. Again, in my numerator, when I take the radical, I get 2 in the top, root 5 in bottom, so I need to rationalize again. So we get plus or minus, which will be 2 root 5 over 5. Now notice again, I need to figure out positive or negative. So if I divide my full angle interval by 2 again, I get the same interval. 135 degrees less than A over 2 is less than 180. Again, in quadrant 2, and cosine is negative in quadrant 2, so my answer is negative 2 root 5 over 5. Let's do a tangent one. Let's write down my tangent half angle formula. Tangent A over 2 is equal to, I'm just going to pick one. Neither one of them holds too much of a advantage here. So I'm going to do the sine A over 1 plus cosine A. Notice I'm given cosine A, but I don't have a sine A yet. Well, I can find that pretty easily. I'll draw a picture. I'm in quadrant 4 here. It's my angle A. Well, the cosine of A is 3/5. So that's adjacent is 3, hypotenuse is 5. Pythagorean triangle, I get negative 4. So let's plug in everything we know. The sine of A would be negative 4 over 5 divided by 1 plus 3 over 5. Now the common multiple between 1, 5, and 5 is 5. So I'll multiply all terms by 5. These cancel, these cancel. So I end up getting a negative 4 on top divided by 5 plus 3, or a negative 4 over 8, so a negative 1/2. And that's my answer. So I'm going to give this situation, the sine of A is negative 12 over 13. We're in quadrant 3. Let's find all 6 trig functions of A over 2. So I'm going to start with sine of A over 2. The sine of A over 2 is, using my identity, plus or minus square root 1 minus cosine A divided by 2. Now I have sine, but I need to have cosine. So what I'm going to do is draw a picture with a triangle and figure out what my other trig functions are of A. Since it's sine, I have a negative 12 in the opposite, 13 hypotenuse, which makes negative 5 the x. So the cosine of A is negative 5/13. Let's plug that in. So you get plus or minus the square root 1 minus a minus cosine. Sorry, 1 minus a minus 5 over 13. So it's a 1 plus 5 over 13 divided by 2. It gives me 18 over 13 on top. So plus or minus 18 over 13 on top divided by 2 divided by 1. So if I flip the fraction, I end up getting plus or minus excuse me, a frog in my throat here. Flip the fraction, we get 18 over 13 times 2, or we can simplify that to 9 over 13 right away. Now notice on top we have a root 9, so it's a 3 divided by square root 13. So I need to rationalize that. So this becomes plus or minus, well, we get 3 root 13 over 13 is my answer. Now remember, I need to figure out what quadrant I'm in using my full angle interval here. So divide each of them by 2. So I get 90 degrees less than A over 2 is less than 135, which puts me in quadrant 2. So think about sine of A. Sine of A is positive in quadrant 2. So we're only going to be dealing with a positive 3 root 13 over 13. That's my sine of A. Positive 3 root 13 over 13. So let's do cosine now. Using my angle identity, it's 1 plus cosine A over 2. I'm going to do this one a little bit quicker. It's the exact same process. 1 plus cosine of A is negative 5 over 13, so this becomes a minus 5 over 13 divided by 2. So plus or minus 13 minus over 13 minus 5 over 13. Well, that'll just give me 8 over 13 on top divided by 2 over 1. So flip the fraction. 4 over 13. So if we simplify this a little bit, we get 2 over root 13. Rationalizing, we get 2 root 13 over 13. Now remember, we're dealing with cosine, and quadrant 2 is negative, so my answer becomes a negative 2 root 13 over 13. And lastly, tangent A over 2. I'm going to use the sine of A over 1 plus cosine of A. What's the sine of A here? We're given that. That's negative 12 over 13 divided by 1 plus the cosine of A. Well, the cosine of A using my triangle is negative 5 over 13. So I'm going to use this common multiple again. Well, 13, 13, and 1 is 13. So multiply all terms by 13. 13s are cancel. So what am I left with here? A negative 12 divided by 13 minus 5. Or negative 12 over 8. Well, 8 goes into 12, so we'll get division by some canceling out some 4s here. So you get negative 3 over 2. Don't have to worry about the sign of it. It just automatically does it for us. Now to find the other three, cosecant, secant, and cotangent, I just need to take the sine, cosine, and tangent of my half angles and flip them. Because that's all they are. They're just reciprocals. So let's start with cosecant. Corresponds with sine. My sine was a positive 3 root 13 over 13. Let's flip that. We get 13 over 3 root 13. We need to rationalize that, though, remember? So let's not box that. Remember, we need to rationalize that. So I'm going to multiply top and bottom by root 13. What happens when we do that? We end up getting 13 root 13 over, I'm going to write this as 3 times 13. My 13's cancel, and I'm getting root 13 over 3. Let's do secant now. Secant corresponds with cosine. So what I could do here is I could just flip this again, or I could take this square root of 4 over 13, which is 2 over root 13, and flip it. We end up getting a negative root 13 over 2. That way I don't have to do any rationalizing, it's a little quicker. And lastly, cotangent of a over 2. To find that, I just need to flip tangent. So we get negative 2 over 3. And that's all 6 trig functions. You just had to find the first 3, and then just flip them to get the second 3. So let's use find tangent of 15 degrees using a half angle identity. So I recognize right away that 15 is half of 30. So I'm going to let 15 be my a over 2. So what is a in this situation? 30. So using my half angle identity, tangent of a over 2 is equal to sine of a over 1 plus the cosine of a. Well, my a in this case is 15 times 2, or 30. So we can write the tangent of 15 degrees is equal to sine of 30 degrees over 1 plus cosine of 30 degrees. The sine of 30 degrees is 1/2 divided by 1 plus cosine of 30 root 3 over 2. So when I do this one, I'm going to multiply each term by a 2. That's my common multiple. So cancel, cancel. We're left with 1 on top. 2 plus root 3. Notice I have a radical in the denominator. So I need to rationalize that. So multiply top and bottom by my, if you remember your complex conjugate here, 2 minus root 3, 2 minus root 3. Forgive me, it's not a complex conjugate, it's just the conjugate. What do I get on bottom here? Because my top is just going to be 2 minus root 3. My bottom will be, let's see, when I have to FOIL this out, the middle terms cancel. We get 4 minus a 3, or a 1. So I end up getting 2 minus root 3 as my answer. Lastly, we're going to prove this ugly looking thing. Now I know I said when I prove identities, you don't touch the right hand side. But I'm going to actually kind of manipulate both sides just to kind of illustrate this. So I'm going to start by manipulating the left hand side. Now I can write this as sine of x over 2 all squared. So let's write my sine half angle identity. Well, that's just going to be the square root of 1 minus cosine of x all over 2 squared. So my square and my square root here cancel. So my left hand side is equal to 1 minus cosine x over 2. That's my left hand side. Now I'm also going to do the right hand side. Do some simplifying. So this is equal to tangent of x is sine x over cosine x minus a sine x, which is all divided by 2 times tangent of x, which is sine x over cosine x. Okay, kind of ugly, but let's just do it one step at a time. This is sine x over 1, so what I'm going to do is get common denominators here. Multiply this sine x term by a cosine x over cosine x to get my cosine x as my common denominator. So this is equal to sine x over cosine x minus, this would be sine x cosine x divided by cosine x, all divided by 2 sine x over cosine x. Kind of ugly looking, but let's just see if something pops out. So my numerator here will become sine x minus sine x cosine x. Which my common denominator is cosine x. Remember, this is all equal to 2 sine x over cosine x. So I can reciprocate or flip the bottom fraction and multiply. So I'm going to multiply both top and bottom by cosine x divided by 2 sine x. Do the same thing on the top. Cosine x over 2 sine x. So everything in my bottom cancels. I also get this cosine x canceling. So let's write what I have now. So this is equal to a sine x minus sine x cosine x, all divided by 2 sine x. So notice on the top, both the sine x and the sine x cosine x, I can factor out a sine x. I'm going to come up here now, up to the top. Sorry for the running out of room, but a lot of stuff to write here. Let's change colors just to illustrate. Okay, so I have sine x times, what am I left with here? Well, I'm left with a 1 in this term, minus, take out the sine x, I'm just left with a cosine x, all divided by 2 sine x. Well, lucky me, these two things cancel. Let's write what I have here. This is equal to 1 minus cosine x divided by 2. Notice that's what I have on my left-hand side and right-hand side, so the identity is proven. Because I just show that the left-hand side is 1 minus cosine x over 2, the right-hand side is 1 minus cosine x over 2, we proved it. So hopefully I didn't lose too many of you on that last one, but go ahead and write your summary and any questions you have. Try out a few of them in the book, and here's your assignment.